What up, guys? Oh my God, this is amazing, isn't it? Are you guys actually enjoying the work, energy, and power? Are you guys actually understanding where this thing is going, where it's coming from, or whatever? I don't know. But again, I have this advice that I forgot to tell you, guys. If you want to understand work, energy, and power to your core, understand Newton laws of motion. If you understand Newton laws of motion, now you're done with work, energy, and power. If you don't understand Newton laws of motion, yeah, you're basically cooked. But we're going to try to help you as much as possible. But it's going to be so much beneficial if you also understand the Newton laws of motion. And again, if you go to the Learning Hub, which is the premium site, we have already taught you the Newton laws of motion. Everything is there for you to go through and understand. If you do not understand, we have a discussion group where you are going to toss a question to say, guys, I did not understand this. So make sure that you do not lose such opportunities. Now, let's actually look at this question, right? Let's look at this problem. Okay. Now, this is a generic Newton laws of motion problem. Let's be honest. The only thing that they have added is this information. Now, they say that we need to find the change in x. So the change in x is actually our displacement or our distance. As you can see, we do not know our distance. We know everything except for our distance. And they say that the object experiences mu k of 0.1. The object experiences mu k of 0.1. Where do we know this the coefficient of kinetic friction from? We know it from the following. We know that if we have Fk, we know this actually equals to mu k multiplied by the normal force. But they've given us a hint. Why did I write this hint, by the way? I wrote this hint because we have learned this from the Newton laws of motion, right? So it means that if we want to calculate the frictional force, we just need to say mu k is 0.1 multiplied by, what is the normal force? So we say it's going to be weight. So weight, it's mg. So the value of m, it is 3. And the value of g, it's 9.8 minus f sine theta. As you can see, it is f sine theta. So the value of f, as you can see, it is going to be 10. So just going to be 10. The sine, what is theta? Theta, it's going to be 30 degrees. Remember, again, these things are so simple because we've already done them on Newton laws of motion, isn't it? So it's 0.1 multiplied by 3 multiplied by 9.8 minus 10, the sine of 30 degrees. So it means that our Fk, it's simply just going to be 2.44 newtons, right? It is 2.44 newtons. It is really simple. It is just straightforward. Now, since now we know the value of the frictional force, it is 2.44 newtons, we can now find the change in x, isn't it? Now, before we go any further, guys, I'm just going to keep on reminding you this. Help Nova grow, guys. Help Nova grow, guys. This is so difficult for us. I'm being honest. When I started this dream, I thought it was going to be so easy to publish this thing to people, but turns out it's not. And one of the reasons that it's actually forbidding us, it's because of finances. And another way, it's because of people who doesn't want to tell their friends and classmates about Nova. It is so stressful for us to move with a platform where people are not using it, right? So the best thing to do is when you listening to this video, help Nova, man. Just go and tell your classmate, just go and tell your friends about Nova. And I want you to understand something. The people that are not telling their classmates and friends about Nova, to me, I see you as the enemy of Nova because we want to grow and you are standing on our progress of growing. And how do you do that? You do that by not telling your classmate about Nova. But just think, what do you lose, bro? To help us grow so that we could, have enough money to fund this project so we could continue going. Just for you to just tell your classmate, to just say, hey, bro, there's Nova, this is how it works, so that you can also pass as well. Because this is more of a mutual thing. You help a person change their future by just letting them know that Nova exists. And in return, we get a Nova user. And then from that, we are able to generate revenue so that we could pay for our servers, so that we could pay for the people that are working here, because people are not working for free. So if you do not go and tell your classmates and friends about Nova, you are basically standing on our progress. And we do not want that, guys. We do not want that. We want to make this platform to be really exciting. We want to work this platform to be so engaging and so humanly. And the best way to do that is when you guys go and tell your classmate, I really need that for you guys to do. So let's actually continue with what we're doing, right? We want to calculate the change in X. So how are we going to do it? I'm just going to say, well, we know that W net actually equals to 1 over 2m. So just going to be V final squared minus V initial squared. So what are we going to use? We're going to use the Newton laws of motion method, which says that the F net is actually equals to the force applied minus the frictional force. Remember that sometimes there would be some other forces involved. I guess you're going to see that one, right? So we're just going to have F net actually equals to what is our force applied. So this is our force applied. However, again, this is coming from the Newton laws of motion. If you have actually interacted with that, we don't just take this force applied, right? We're going to take these X components, which is going to be FA, the cos of theta, right? So in other words, this is going to be FA, the cos of theta minus the frictional force. So FA is 10, the cos theta looks to be 30 degrees minus friction is 2.44. So this is our F net, isn't it? So our F net is going to equals to, so it's actually 10 cos 30 minus 2.44, which is actually 6.22 newtons, right? So now we're just going to say work net actually equals to 1 over 2m V final squared minus V initial squared. Now, guys, if you want to join the Nova Learning Hubs, which is the premium... Oh, my God. There's something on my throat. This is crazy. But again, as I was saying, if you want to join the Nova Learning Hubs, which is the premium side of Nova, for you to get everything already arranged for you, just go to your web browser. I'm just going to open a new page, and you're just going to search the phrase student, okay, student, I'm not doing it, studentport.co.za. Just gonna press go. You're gonna land to our amazing page, right? And just gonna go to join learning hubs, and you're just going to be there joining the learning hubs. I don't know why it's not working. It's not working. It's seriously not working, but it's fine. So after pressing join learning hubs, you're just gonna come here, isn't it? And here you're just gonna see this amazing pricing, and you're just going to choose the budget that works for you. If you want to take math and physics, or math, physics, and life sciences, or just one subject. So make sure you actually do this one. So let's actually come back here, right? So we know that this W net is going to be arranged as the F net, and we're just going to have change in X, and we're just going to have the cos of theta equals to 1 over 2m V final squared minus V initial squared. Now, what is our F net? As you can see, our F net, it is 6.22. So just going to write 6.22. And we're just going to multiply this by what? By the change in X. By the way, the change in X, it's what we are looking for. And we're just going to have the cos of 0 degrees actually equals to 1 over 2. The value of M is 3. What about V final? So V final, it's actually 9 squared, right? So I'm just going to write my 9 and then I square it minus V initial is actually 6. And then I'm just going to square it as well. So it's just going to be 6 squared. So, by the way, the cos of 0 degrees, it's 1. You might have shown that. So it's the same as change in X, 6.22 equals to, I'm just going to hit everything that's in here and put it inside the calculator. So it is 1 over 2 multiplied by 3. So it's 9 squared minus 6 squared. And this is just going to give us a 135 divided by 2. So let me just divide both sides by 6.22, isn't it? So So I'm just going to divide both sides by 6.22. So the change in x is going to equals to what? 135 divided by 2 divided by 6.22. And the answer that I get, oh, this is crazy. It is 419.85 meters. Yeah, this answer is so wrong. By the way, I've made this question up, so that's why these answers as they are. This is crazy. It's really ridiculous if I'm being honest with you. It is really ridiculous, but it's fine. This is the change in x that we actually found, isn't it? So that's how you do these types of questions. This is how you solve work, energy, and power if you are given states like this. With that being said, guys, keep on practicing, keep on using Nova, and I'm just gonna see you on the next video.